So welcome to our channel Electronics on Wheels. So many of you have requested to make the videos on capital logic and capital XE. So last time we have shown you that we have posted around 5 articles on a different topics, like what is the Tesla's 48-volt architecture, or will the 12-volt architecture will die in the future, what is the development process, and what is wiring harness. However, we will write more article on wiring harness and how it works, but there is a one demand which came from many platform, that how to use the chs capital logic and XC. Please continue this series and make more videos on that. So I have started this particular series, and we are trying to complete this particular series in around 4 to 5 chapters. So let me start. So if you want the document of this, how to use the capital, so you can go to electronicsonwheels.com. So this is our website and it is made to help you. So let me go to the article which we have written, and I will try to explain the what is the use of chs capital logic and XC in the wiring harness design. So this article is written in the form of course. So this course will contains around 4 to 5 chapters where we will cover all the aspect of capital logic. So first we will cover the capital logic, then we will go to the capital XC, and then we will move to the CATIA 3D. So capital logic, as you are aware that this particular software is used to create the schematic. So there are different chapters where we are going to cover this particular software capital logic. So this course will give you the exposure of the wiring harness and technical understanding of different system. So first, this is the table of content which we are going to discuss today. So first is the introduction of capital logic, what it is. Then what is the GUI? We will see the first, when you run or launch the capital logic, then how, what type of GUI it comes, user interface. Then example of logical diagram in CHS. So we will see in capital logic how the logical diagram look like. Then essential requirement before starting and with capital logic and the capital XE. Then we will try to understand the capital library and symbol, and how we can create the capital logic, uh, how we can create the new projects in the capital logics. And then I will give you in the last what are the topics we are going to cover in this particular course, which we are going to cover in 4 to 5 chapters. So in chapter 1 we will try to understand these 4 to 5 topics. So let me start with the introduction of capital logic. So capital logic, CHS, basically this is a whole complete software suite which contains a different set of software packages with the essential of wiring harness creation. So we will try to discuss the 4 to 5 essential software package which is useful for the wiring harness. There are different other uh, packages also which are used for the simulation purpose, analysis purpose, we will see. So the first package is capital logic, so which helps in the schematic creation. You can do the simulation and the report generation. Report generation is nothing but the bomb. So this is the thing which you can do in the capital logic. The second part is the capital XE. In capital XE basically helps in the 2D drawing creation. Once you create the logic diagram, then you have to create the 2D drawing for that particular logic diagram. So it will help you to create the 2D diagram layout creation, which is used for creating the form board creation, which goes to the supplier actually. So it also helps to create the BOM, bill of material. So from here also you can get the bill of material, but in this you will get the component bi- bill of material, but here you will get the whole supply BOM, bill of material, which is used for the supplier to for the costing purpose. We will discuss this particular thing in detail, how to generate the BOM and what is the use, because we give some estimation to our team. Suppose you are working in OEM and you have one supplier for the wiring harness creation. There might be different suppliers to create the wiring harness, and you onboard one particular supplier for creating the harness. So what basis you onboard that particular supplier? That is first thing, like quality, and second thing is the costing. So there are many other factors also, but these are the two main factors where we see. So costing, how you decide? So first you should know the costing of the your wiring harness. That costing comes from the bill of material. Okay. The third part is the capital symbol. So capital symbol which helps to manage the capital library actually for creating the schematic. So this is like symbol that you can see the graphic creation. We will see what type of symbol we have in the capital symbol library. And last but not least, that is the capital library. So this is used for the manage the database of the component. So capital symbol and capital library is more or less same. So you might be having some symbol segregated on the capital symbol, and capital library actually used to manage the database, where you create the new symbols or new components and new definition for the schematic. So coming to the capital logic, actually is a very powerful tool which helps to create the wiring harness in the digital environment, and it will implement your logical design which you have created in the form of schematic to the physical wiring harness, that is our 2D drawing. So capital logic is a schematic design tool. Once you created the schematic, then 2D drawing will be created under with the capital XC package, which covers the which converts the your logical design into the 2D drawing. Capital logic provides the simulation analysis as well as which helps in the validation of the circuit. Example like voltage drop. So let's move to the second point, that is our Capital Launcher GUI, graphical user interface. So once you click on the CHS on your system, then what type of graphical user interface comes and what type of packages you can select from this. So whatever packages we have discussed here, we have mainly discussed four packages. So we will see in the GUI. So when you run the Capital Launcher on your system, a GUI pop-up will come up on your screen, and which will ask you to select the package of the CHS which we have discussed earlier. So there are, you already know, there are many different packages. So mostly we will use two or three packages. One is the Capital Logic, that is design, sorry, this one, and Capital Harness XC, and capital library and capital symbol. Sometimes capital user also we use, so that is different thing. I will tell you why we use. And mostly capital library and capital symbol is used by the librarian, which used to handle the library things, like creating the symbol and creating the definition of the schematic if the new things are coming up. So however, we will use the two packages very frequently, as I told you, the capital logic and one is the capital axis, to create our 2D drawing. So let's move to the how it looks like. So when you search your capital launcher in your run tab, so you will get this window. So first thing, I just want to tell you that this particular software is not free, and you will not get freely available on the online as well. So this uh, software you can learn from here, that what are the process and what are the things, but you cannot do the practice. So please try to understand this thing. So mail, but the process and everything would be same, whatever I am discussing here, that would be totally same, that won't be any different. So let's see. Once you search the capital launcher in the run tab, you will get this particular window. So the first thing, like info hub configuration, then in define and design, you will get these four packages: capital design, capital harness axis, capital logic, and capital integrator. So you have to use most of the time this one and this one. this one, capital logic and capital axis. As I already told you, this is used for the schematic creation and this one used for the 2D drawing. Now product and maintenance. So as I told already told you, so you have no need to use all these stuff here. This is related to the process, cost models and other things. um, there are many things you can do in the capital, but we are not using these stuff. In asset and enterprises, as I told you, you are a librarian and you have to work on this, that capital symbol, capital project, how to manage the project. So once you have the new project in your uh, you know in your OEM or wherever you are working, so you cannot directly work in the capital logic on that particular project. First you have to create that capital project here, then it will start reflecting in the capital logic. So this is how you have to manage the your projects: capital library, then capital user, and capital enterprises and report service. So mostly we will use this one also, capital library also, and capital project and capital symbol. Those things are used by the librarian mostly. So this library thing is uh, mostly is one person or two person from the team used to handle, not the everyone, so that uh, uh, no mix up should happen. That is the only purpose, to that two-person or one person is working on that. So let's move to the next thing. Sorry. So first we will try to understand before jumping to the how it works. Okay, before jumping to the capital logic software, first we will try to see how it looks like and what are our pre-requirement to make the semantic in the capital logic. So we will see how to read the semantic in capital logic. So let me take you through the this sheet. So before jumping to the capital logic software, we will try to understand how to read the semantic in capital logic and how it looks like in capital logic. So we will try to understand the each and every point. So many times I have told you this is a circuit of starting system which we have made. You can see my one of the video where I have discussed the starting system in very detail, that how it works. So we will take the same example and we'll try to understand, if I want to make that starting system in capital logic, then how we have to do and what are the things we have to take care. So like before jumping to the capital logic, as I told you, we will try to understand the basic component of any semantic and how to read the capital semantic. So if you see this particular semantic, let me see here. So there are three type of portions we have, three different portions we have. The first is upper one, this portion, and the second one is this portion, and if you see the third is the middle one. So the first portion is comes under the power distribution. So most of the things in the upper side we will try to manage in the power distribution, but you don't say that we cannot put, but we try to manage the things. The okay, that on upper portion, the most of the time we will put the things which are related to the power distribution, like first fuse, then you can put other inline or other things like relay. So second, the middle portion we will try to put the wires or the relays and other things or the components. Then the lowest portion we try to put the grounding. Okay, so that we make one flow, like from power distribution to the component and then grounding. This is how our circuit will complete. But you should not you should not think in that way that you cannot put your component here. You can put your component here and fuse here, still it will work because this is a software. Okay, but to try to understand the better things, we should maintain one hierarchy. So in first we will try to put the fuse box related to the power, then we will try to put the components in between like motor, starter motor or relay and all these things, and in last we will try to put the ground, so we will make the flow. Okay, so I hope you understand why we are putting like this. So this is what we have written here also. The first section, which is power distribution, comes in upper, and sorry, the second section which have the components in the middle, and in last, that is downside, that we try to put the ground distribution. So now we will try to understand each and every aspect of this schematic. So you can see here, on this. So we have written here few things. So F6 we have written here. So what does it mean? F6. F6 basically denotes the numbering of particular fuse. Okay, and which is printed on your fuse box also. That fuse box cover is there. So on that fuse box cover, it will be printed. Why it should be there? Because it helps you to identify the particular fuse in the serviceability. So suppose once your vehicle have some issue after the SOP and it goes to the service center, then how to find, how the service person, technician, how he will find out the fuse is which one. Okay, so because of that numbering, that we put in the fuse box cover. Okay, this F6 would be this, F7 would be this, F8 would be this. Okay, so that is the identification purpose, so to make the serviceability easy. Now when you are putting the numbering or the name of the fuses, then you have to put the value of that also, so that the technician or other thing, sorry, the technician, not only technician, but you should also be aware when you are creating your schematic. Okay, how much fuse or which number of fuse you are using. Okay, for the fuse numbering also you have to identify that which one is the which fuse. Okay, so F6 is 15 amps fuse, F7 is the 10 amps fuse, and F7 is used for the headlamp, F6 used for the other stuff, horn or something. Okay, you can take any example. So this value, this 15 amps, this called is a fuse rating. So fuse rating basically denotes the protection given to the particular wire based on the continuous current. So I have already told you that how to select the fuse for that particular circuit. You just go through those videos, you will come to know what is the continuous current, what is the peak current, what is the inverse or transient current. You will try to understand those stuff on those videos. I have already made those videos. You can ask if those videos are not clear. I will try to provide more videos on those topics. Then wire color. So wire color is given here. You can see here. Sorry. So wire color you can see here. This wire color is given to identify that particular uh, color of that wire. So this is also works in the serviceability, because if you will give the same color to each and every wire, then the technician or service person will not be able to identify that which wire is going for which purpose. So it's always better to give the wire color, different wire color, uh, to different wires, so that it is easy for technician to identify that this particular wire is going for this. And there are some standards also, like for power distribution we use the red always, because it is easy to understand for the technician. Okay, this particular wire is going for the positive. For the grounding we use the black color, so it is very easy for the technician or service person that it is going for the grounding purpose. Okay, then circuit number. Circuit number is nothing but it tells you. So you will have after, I have told you like there is a kind of bomb. So bomb is nothing but or wire circuit table where you will find out which circuit is going from which one. So this called is a from and to table also. So suppose if I don't give the circuit number, then I will not be able to identify that which circuit is going from which one. So suppose if I take the example of 214. So 214 in this, it is clear that this particular circuit is going from this point from fuse to the relay. So it is very clear for from the circuit numbers. Then relay code is nothing but that particular component is given one particular reference, okay, that name, or you can call it denum. So this is given to the relay or any component to relay holder to identify that particular component. Then we will try to understand the right hand side also. Interconnector is nothing, or inline connector is nothing but where you have the one particular harness is coming. Suppose I take one example. It is coming on engine harness and it is coming on passenger harness, and you want to integrate those harness because of many reasons. I have explained this particular concept in inline connector video, where you can see how we are using the inline connector and why we should use the inline connector. So one side it would be male and other side it would be female. So it depends on the parking position or packaging location where you want to put the female and which side you put the male. Okay, so it is not necessary where you will put here female side and here you will put the male side. It is up to you, and up to depend on the parking position as well, that where you want to put the male or female side. Then we will go to this. This is a starter motor, as I told you the component, and this M24 240. M240 is nothing but the denum of that, or you can say the you have given one naming to that component, and this is nothing but the component name, and this is final the body ground. We will try to understand other aspect on the right side also. So here, if you see that there is a written 2, so what does it mean? Cavity numbers. Then connector code. Cavity numbers is nothing but, so suppose this is my connector, and you have to find out which cavity number. So 1 2 3 4 5, so this is the cavity number. So suppose I am taking from this connector pin number 2 and pin number 1. Suppose here it is pin number 1, then pin number 2 and pin number 1. You cannot take the same pin number. I'm sorry, here it is written 2, here also it is written 2, but one side it would be 1 or one side it would be 2, or it might be 3 and 4 also. Okay, it depends on the which type of connector you are using. So here if you are using two pole connector, it would be 1 and 2 only. Then you have the switch code, and this is nothing but, as I told you, this is the mm, connector code. Then wire CSA, that is always would be in square mm, and 0.5 2.5. So always it is in square mm, which also you have to give in the your schematic to identify that which wire CSA you are using in your vehicle. Then already I have told you that inline connector male to female, so one side it would be male and other side would be female. Then relay holder and relay. So what does it mean? So first, your this would be your relay, right? This would be your relay, and there should be something which will hold it. Okay, so this is called relay holder, this one. So this particular relay would be going to shift here or would be fixed here, and then after that your wires will be coming from the downside. I hope you understand. These are the terminals. This is nothing but terminals, and then you have the male and female, and then splicing we will see. So splicing is nothing but, suppose you want to take the same grounding. So suppose here we are taking the ground. So suppose you want to take the same grounding from this point, so you can take one more wire and you can connect here. So it will take the splice. Okay, so suppose for switch also I am using the body ground, this switch, and suppose I am using for the horn also the same ground. So what you will do, from horn grounding you will just connect one wire from here and it will be grounded. This is splice number or naming SP2021, anything you can put. Okay, but it start with the many different OEM use different naming of this. So you can put S200 or something like naming. There is a nomenclature is there, so you have to follow as per, but the naming is will not affect much. The this is just a splice number and this is your ground. I think I have covered most of the things. If I missed anything, so suppose this is your fuse, the particular fuse, then your fuse is going to fix in the fuse box. Then wire color, circuit number we have covered, then relay code we have covered. Then this is your component, suppose a starter motor. Then body ground, you know already, I have already explained. Then you have the inline connector, splices, male female. So already most of the things I have covered. So these are the things you are going to use in your capital logic when you are creating, so you should be aware. See, okay, and it will look like this. So your inline connector looks like this and your switches look like this. So you might be seeing that why this is shown like this. So it shows in capital logic this particular thing, that this particular inline connector might be used in some other sheets also. So suppose you have one inline connector, it doesn't mean that you will be using one pole inline connector. There would be multiple pins in that, suppose 20 pins. So suppose one pin you have used here in this for this purpose, but other 19 pin you might be using some in some other system like charging system or the headlight or the ECU. So they might be using in that, and that's why this symbol goes like this, you can see here. So I think we are good in understanding. If I missed anything, you just comment in the comment box. So we have covered fuse number, fuse rating, wire color, circuit numbers, relay code, relay base connector, what it is, inline connector, then component name, grounding we have connected, then discussed, and splice we have discussed. So we are good on this. Let's move to the move. We have already seen the what are the requirement in the capital logic circuit and how to read the schematic in the capital logic. So now we will see the essential requirement before starting with capital logic and XC. So we will make sure few parameters. So like all the parameters names should be unique. So as we have seen already that there are different parameters like circuit numbers. So circuit numbers should be unique. You cannot put the same circuit number for the two different from and to. You might have seen the circuit number there, or fuse numbering. Fuse numbering, you should not put the same fuse number for the 5 amps also or 10 amp also you are using F6, and for 10 amps also you are using F6. Then it will create the conflict in the capital logic. So you should use the different or unique naming for this, like circuit names, connector name, splice name, all the references name given to the component uh, and so on should be unique. Then wire size, sorry, then wire size with accurate information of the terminal, wire seal, dummy plug need to be documented in library. So I will tell you why we want this particular information when we will go to the chapter second, because all the wire size information is taken automatically, like terminal number, wire seal, dummy plug in the capital logic automatically. But from where it will take automatically, because nothing is automatic, it will take from somewhere, from library it will. So the terminal numbers, wire seal, dummy plug, when once it is documented for the that particular wire CSA, then only it will come to the capital logic. So suppose 0.3 wire square wire I am using. Okay, suppose I am using FLRY. So for this particular wire, it is already documented for that particular connector. You can use this particular terminal and wire seal and dummy plug. Okay, so it will automatically take all these things in your capital logic schematic or wire table, and from where it will take, from library it will take. So all symbol and graphic of the component to be documented in capital, which need to be taken care by librarian. As I already told you that these stuff are taken by the librarian. And if you do not have the symbols and the graphic, I will show you how it looks like. Already I have shown you that how the symbols, and we are talking about these symbols. So these symbols is not, like automatically it will not come. You have to create first in the library, and then so this particular stuff is done by the librarian. You have no need to worry on that. So this need to be taken care. These are the prerequisites. Then we have the library symbol. So what is the library symbol? So capital library is the database of the component which is used in different projects. Of course, that capital library is used to manage the supplier and customer part number as well, symbols, views, all other details. So you might be having one supplier part number and customer part number. Customer part number is nothing but the OEM part number, and supplier part number, suppose you are one OEM BMW. So BMW will be having his own part number. Okay, part number for one connector, but supplier is maintaining for the same connector the different part number, and those things would be there here in the library. Then capital symbol devices can be presented either by rectangular block or having pins, or by using the predefined symbol. So we have already told you that this is just for the understanding these symbols. It doesn't affect anything uh, on the schematic, because you are creating the uh, till female connector. You are just creating the wiring harness, you are not creating the devices. Symbols are predefined graphical representation of the devices and maintained using the capital symbol. There are many different type of symbol like command, devices, ground, border, backcell. So command, for command also there is a symbol. I will show you some when we will discuss the you know capital logic. So symbols are placed by double clicking on the required. So this is the interface which comes on a capital logic. So if you double click on those symbols, I will explain each and every things I will explain, that how what is this ribbon, what is this project window, what is this working area, I will explain. But as of now you just understand. If you want to put the symbol, so you will just go to in this particular option, and in from the symbols you just double click on that, and this is the symbol, so which will come in your schematic automatically. Once the device and ground is added into diagram, a name is automatically applied to the symbol. You can change the name of the device according to your requirement as well, but it is not recommended to change the name of any device, because it is already predefined as per the project, and you should not do like this. So let's move to the next topic. So next topic is creating a new projects in the capital logic, and we will try to see here the GUI of the capital logic. So as I already told you that there are uh, four capital packages we have, which we are going to use most of the time. So capital XC and capital logic. So for schematic we are going to use the capital logic. So in capital logic we are going to use for the schematics, right? So for the schematics, once we will double click on this capital logic, or once one click itself, then this particular window will open. I'll show you. This particular window will open, this one. So we will try to understand the GUI of the capital logic, what it means, and how we have to read. So we will try to understand the graphical user interface of capital step by step. So the first thing, that is called ribbon, and in ribbon we have most of the things to draw in the diagram window. So the way we are going to create the schematic, most of the things we are going to take from the ribbon. We will try to understand what are the things in the ribbon panel. Then we have the project window. Project window is nothing but where we have our project, which project we are working. There might be different project also here. So in which project we are working, and we will see here. We will create the logic build list also from here. So we will try to see once we will move forward. Then this is our design window, as I told you, like design symbol parts, all these things you will see here. Analysis also, the reports also you can generate from here. Then you have the information and feedback window. So whenever you do something, like you create something, then the information will come here. Or suppose you build the logical build list you create, then suppose some errors is coming, that is this window you will get. This is like information of feedback windows. So let's move to the first ribbon bar. So in ribbon bar contains all the options in the home tab, which is used to create our wiring harness in schematics. So what are those symbols or options? So first is the option is device. So already told you that what is the meaning of device or component. The device is similar to the component name. Then splice. So we already discussed the what is the splice and how we are going. So you will get the splice symbol here. You can see here. You can see here the device. Then you will be having the pin. So pin is nothing but the particular pin you want to give for that particular device or the connector, you will get from here. We will see here how to use. Then you will be having the wire. So wire is nothing but from one connector to other, and if you want to put the wire, and this is how mostly we are going, this is the one which we are going to mostly use. Then you have the multicore overbraid. Multicore is nothing but you know that we have the twisted wires and other things, so we will give from here. Then you have the connectors. So this is the one which is we are going to use most of the time. So connector, which plays very important role when you are connecting your wire. So wire and connector, these two things we are going to use most of the time. Then ring terminal. So ring terminal, as I already told you. So this is the for grounding purpose, or you can use for the power distribution wherever it is required. So ring terminal mostly you know that for grounding purpose we use, or the power distribution also we use. Then this is the shielding option. So shield is nothing but you know that for EMI EMC effect we give this thing. Then you have the move option. So this move, merge, and flip and X reference, these are the beautification options. So it won't place more role in the schematic, but it will beautify your circuit. So you want to move some of the things, you want to flip the symbols, you want to make some references, then you can use all these beautification symbols. The technical symbols are these many which we are going to use, and how to use we will see in the next videos, the chapter 2. Then project window is uh, where you have the overview of the different projects from different cars. So all created projects will come under this tab. Okay, you can see here. And if you have created new project, it will reflect here. As I had already told you that librarian will create the new project and it will reflect here, and you will select that particular project and then you will start working on that. It is not like that new project, without creating the new project you will start working, or it will start reflecting here. If there is a new project, then librarian has to create. You can create the build list in this build window also. Now, I have not shown here the options, but it will be there. I will show in some other video. which will help to synchronize between the capital logic and capital XC. And we will cover this topic in the coming slides or coming chapters. So once you made the build list, logical build list also you can say, then you have to integrate or synchronize that particular list with the capital X, and capital X is used for the 2D drawing. Then your 2D, whatever you have created in the schematic, it will reflect in the 2D drawing. We will see that one. So this is called our project window, and I hope you understand what does it mean. Then we have the design window. So in design window will give you the overview of the components used in the project. So whenever you have used one particular splice and you click on that splice, and you will see that particular splice in how many projects is used. Or suppose one component you can take, or wire you can take, you can see that particular wire, how many seats or how many diagram it has used. Okay, so suppose this particular one wire we have taken like 214, suppose. Then if you click on this wire, then it will reflect in how many diagrams it has used. That you can see by this particular window, design window. So from design symbol you can see parts, you can analysis also, you can audit the reports, and you can see the groups as well. So these stuffs you can do in the design window. Then information or feedback window, as its name suggests, it gives the information about all the activity which you have performed in the diagram window. Diagram window is nothing but where you are working actually in your schematic. So whatever schematic you are creating in the diagram window. You are creating your wire, you are creating your components, devices, all these stuff you do the diagram window. Okay, this is kind of workspace for you to create the schematic, which will help of with the help of all the options, ribbon, toolbar, which we have discussed above. So this is your diagram window. See this one. So I hope I have covered most of the things about the GUI of Capital Logic, and we will try to understand in the new chapters, next chapter, that how to use all those stuff. So I need your support, and the support, what you can do, you can visit my website and post the comments there. If you like the content, if you don't like the content, still you can post the comment. I will show those all those comments, and we will try to improve on those stuffs. And these videos are the voiceover which are has taken the help from the other different people. So please give the feedback on those also, that audio I got. So till here we have covered, you can see in the content list. Then opening the project, naming and convention of default name, how to manage the variant option in Capital Logic, creating design, different border and style, how to add devices in Capital Logic, parametric symbol, adding connectors, part numbers, how to manage inline, how to use the ground terminals, managing the wires in Capital Logic, regular wire, twisted wire, shielded wires, shared object in the CHS, then shared objects in the pin creation, what is the build list, which we were discussing how it used to integrate or synchronize the from Capital Logic to Capital XC, design management, printing the design validation, we will see the DRC, what does it mean, why we do, then simulating the circuit and generating the reports. So all these points I am going to cover around 4 chapters. So as I told you, that you can comments on my website article which I have written on that electronicsonwheels.com, and already five articles I have written, you can read on that. So please comment on this blog post which I have written, and the content also I have created here to help you, so that you can go through anytime and you can check what does it mean. So please comment, you leave the comment on this, here you can leave the comments. If I got the 100 comments on this post, definitely I'm going to come with the chapter 2, chapter 3 and chapter 4, where we are going to cover all these stuffs which I have already discussed with you. So thank you for your time. Please like, comment, subscribe my video if you like the content.